You are going to plug in the x that are given to you into the expression. So and find the number, and then you're going to do and find the number. What is negative 3 to the fourth?
81.
Why is it not negative 81?
Because it's 3, negative 3 times negative 3 times negative 3 times negative 3.
Perfect. On number 2, we have a negative 2 squared plus 1. What'd y'all come up with that number being?
Negative 3.
Because you have negative 2 squared is 4 plus 1, which is negative 3. So when we do the 3, it's going to be a negative 3 squared plus 1. And what do you come up with?
Negative 8.
Then we're going to go on to 3. We have the negative inside the parenthesis this time. So a negative 2 squared minus 1. So negative 2 squared is what?
3. I went negative 2.
All of it's 3, and so that'd be 4 minus 1, which is the 3. And so we have a negative 3 squared plus 1. So that makes that positive 3 when those combine. So we have 10 as our answer. Because a negative 3 is positive 3. Positive 3 times positive 3 is 9. 9 plus 1 is 10.
Should it be minus 1?
Oh, is it supposed to be minus 1?
Yes.
Okay. Then it's going to be 8.
Okay.
Sorry. I got which one was a positive, which one's a negative. Okay. And then number 4, we're going to take 2 to the 8th power. What is 2 to the 8th power?
256.
What is negative 3 to the 8th power?
6,561.
Just make sure that you put the negative inside the parenthesis with it whenever you find that in the calculator. Otherwise, the calculator is not going to give you a positive number. It's going to give you a negative. Because it assumes that negative is separated if you don't have it in parentheses. They assume it's not attached. So we're talking about power functions today. Power functions are something like f of x equals some number times x to a power. So f of x equals 3 times x to the 10th. F of x equals negative 1, x to the 4th. Those are all examples of power functions. So the exponent can be anything as long as it's not 1 and it's positive. The number in front could be 1. It could be, only thing it can't be is 0. Because if it's 0, it kind of cancels out everything. And so we're going to look at each, and I guess it can be 1, it just we don't usually think of that as a power. So the first one is a linear function. This is a linear parent function. I want you to find the domain and range of each of these functions. Okay. So is that the case for all of these?
No.
Not the quadratic.
The quadratic is the only one that doesn't have this set. If I can write. What's different on the quadratic?
The range.
The range. So the domain is still negative infinity to positive infinity. But the range is from, and this one, domain, we're back to that other set. So what is my x and y intercept on all of these?
0.
And so all of them have the same x and y intercept. So we're going to actually take and figure out what happens when we do different things. So when the a value is negative, that means there's a negative in front of it. So that would be negative x for this one. What would change about my graph? What is different?
The line go the opposite way.
Line goes, falls as it goes to the right. What would happen to my parabola? So it would become negative x squared, wouldn't it? If it's in the front, or would it become just a positive x squared? Okay. So what does that change about my graph?
It would flip the parabola of the x-axis.
So on my cubic, it's going to become negative x cubed. So originally, as I went right, I went up. As I went left, I went down. What do you think it's going to do if I have a negative in front?
It's gonna go
It'll flip over the y-axis.
Not over the y, over the x-axis. But it looks the same as if it was flipped over the y. You can't really tell a difference, but if it's ever in front, it's always a reflection of our x-axis. So now we're going to look and see if we had what we plugged in was negative, what would it do to the function? So if I plugged in a negative x, what would it do?
Make it positive.
No, not for, if I was plugging in negative x there, I'm just making a negative x. So what would my graph look like? Like the same one we just had. If I was going to take a negative x and square it, what would my graph look like?
X. So the normal.
It looks normal. If I can draw a normal. If I was to put a negative x into x cubed, would it be a negative x cubed or a positive x cubed? So what would my graph look like?
Where it starts at the top and ends going down.
So why is it the x squared did not change?
Because it's negative times negative.
Okay. So if I was to say these reflected, what would you say these reflected over?
X.
The y-axis. Any questions on that before we go? So which of these graphs, the next question says, or asks you to determine, or talks about determining which graphs have symmetry. Which graphs of these have symmetry? What does symmetry mean?
And on both sides.
Same on both sides? So,
Or it can be folded,
okay, it can be folded.
so would that be X and X2?
Okay, how would you fold the x graph? What line, where would you fold it over? Because if I folded it over the x-axis, it won't work.
You could fold it over like the,
Both?
Origin.
yeah.
Yeah.
Fold it across the origin. And so if I fold it over, oh, I have my dashed line. That really did not work well. I folded it over this line. Yeah, I can see that. And so if I fold it over y equals negative x, that's that line. What can I fold this line over? Y-axis. What about this one?
You can't really fold it.
Okay. So the one that's the truest is our our quadratic. Has symmetry over the y-axis. Linear is over x, or excuse me, y equals negative x line. So we're going to talk about odd and even functions. An even function is always symmetric across the y-axis. So with that information, which of these is an even function?
The quadratic.
The parent function is even. And we'll talk about if it goes, how you can tell if it's more or not. So if we're looking at this graph, is there any way we can fold the positive side to get to the negative side? Olivia says that there's absolutely no line of symmetry whatsoever. Randall says there must be, because this is 1, 1, and then we have a negative 1, 1, or negative 1.
He says that it has no line.
Oh, it has no line of symmetry because there's no way to change it. Sorry. I was thinking it was the next one. It's Shedrick that says that he notices this pattern that at 2, 8, that's going to match up to negative 2, negative 8. So there's some type of pattern here. He says it must have done both the x-axis and then the y-axis. So you're going to have to fold it twice.
That's what I was thinking when we originally said.
Yes, me too.
Yep. You're like, but it can't be that, right? It is. And so it's actually called symmetric about the origin whenever it's a double reflection like that. So if it's ever a double reflection, then it's symmetric across the origin. And what that means, that if I was to plug in a negative x it'd be what was reflected across the y-axis. And then if I was to make the function negative, it would get me back to the original. So even has symmetry across the y-axis. That means if I plug in a negative x, I get the same thing as what I started with. And we saw that with when I plugged in a negative x and squared it, it became x squared, which was our original. Well, odd is symmetric across the x and y. So that means I have to do both what would get you across the x and what would get you across the y. And so, like, let's take x cubed. So if I was to make the entire function negative and plug in a negative and cube it, would I get back to x cubed? Well, negative x to the third power is negative x cubed. A negative negative is a positive x cubed. So yes. And this is the test to see, is it odd or even? If you were to take and make everything inside it the opposite sign, would you end up the same as what you started with? Then it's even. If you make the function outside plus change all the signs on the inside, would it make it the same? And then if that's the case, then it's odd. So what you know about the A and B values, the B is when we plugged in a negative, the A is when we had the negative on the outside. Describe the odd and even functions in your own words. So think about, what would you word that as?
You see a double definition.
Well, that's the plug-in part, but how would you describe the transformations?
They come out looking like the parent function.
They come out looking like the parent function if it's an odd. And so the way I put it is the odds are identical to their reflections across the x and y axis. And even is the same if you reflect it across the y-axis. Is Clara, or explain why Clara is correct. Use function notation to write her conclusion. So Clara says, the reflection of an odd function across the y-axis produces the same graph as a reflection across the x-axis. And so let's look at it. What she's saying is if I'm reflecting it across the y-axis, is that when I put a negative inside or outside?
Inside?
Outside. Y is outside. X-axis is the inside one. So let's take this and use it. So what that means is a negative x cubed is going to produce the same graph as a negative x raised to the third power. Is that true or false?
True.
True. And the same thing works if I have a negative x to the fifth. It's going to equal the same thing as a negative x raised to the fifth power.
So,
Is that true? So this is for odd. Yes, go ahead and ask your question.
So when it's on the outside, it's the y-axis and the inside is the x-axis?
Oh, I said that backwards. You're right. This is the x. And this is my y. So even, would it work the same way? So let's take an even function. What's the one that we said was even? quadratic, so x squared is even. So if I put a negative x squared, does that equal a negative x raised to the second power? No, because this is going to become an x squared, and that's a negative x squared. So it does not work for even. So this is a test to see if it's an odd or even. And it's easier than doing both of them most of the time.
Can you go back?
Yes. Okay. So is A symmetric across a line, a point, or neither? Oops. So what's it symmetric across? Or is it none?
A,
Hey,
line,
it's symmetric across, well, that line. What about B? Neither. What about C? Because I could take and move that up there. Another way to see this is if I take an ordered pair from one side and change the signs on both of them, will it show up on the other side? So I want y'all to, for homework, I'm going to graph these three and determine if it's even, an odd function, or neither. Then describe its symmetry.